Welcome back to the channel. Today, we're diving deep into one of the biggest mysteries of our planet's history, the extinction of the dinosaurs. For 180 million years, these incredible creatures ruled the Earth. They were the apex predators, the giants of their time, and then, suddenly, they vanished. How could creatures so powerful, so dominant, just disappear? It's a question that takes us back to a cataclysmic event 66 million years ago. Join me as we explore the theories, examine the evidence, and try to piece together the events that led to the end of the dinosaurs' reign. Picture this, the late Cretaceous period. The Earth is a very different place. Continents are not in their current positions. Dinosaurs, both large and small, roam freely on land. Giant reptiles rule the seas and pterosaurs soar through the skies. The climate is warmer than today, and lush forests cover much of the planet. Life is thriving. But unknown to the dinosaurs, a cataclysmic event is on the horizon. Over the years, scientists have put forward various theories to explain this mass extinction event. Some theories point to gradual changes in the Earth's climate, while others propose more dramatic events like volcanic eruptions. However, one theory stands out due to the sheer scale of its potential impact, the asteroid impact theory. Imagine an asteroid, miles wide, hurtling towards Earth at unimaginable speeds. The impact would unleash unimaginable forces, triggering earthquakes, tsunamis, and wildfires on a global scale. The atmosphere would be choked with dust and debris, blocking out the sun and plunging the planet into darkness. Our journey into the asteroid impact theory begins with a trip to the Yucatan Peninsula in Mexico. Here, hidden beneath the surface, lies a massive crater, the Chicxulub crater. Spanning over 180 kilometers in diameter and 20 kilometers deep, this colossal scar is a testament to the unimaginable power of the asteroid impact. Discovered in the 1970s, the Chicxulub crater provided the first concrete evidence to support the asteroid impact theory. Its age, about 66 million years old, coincides perfectly with the extinction of the dinosaurs. By studying the crater's structure, composition, and the surrounding rock layers, scientists have been able to piece together a detailed picture of the impact and its aftermath. Imagine an asteroid, estimated to be around 10 kilometers wide, hurtling towards Earth at a speed of over 70,000 kilometers per hour. The impact, when it finally came, would have been unlike anything our planet has experienced before or since. The energy released would have been equivalent to billions of atomic bombs detonating simultaneously. The shockwaves from the impact would have radiated outwards at supersonic speeds, triggering earthquakes of unimaginable magnitude and generating colossal tsunamis that would have raced across the globe. The massive amount of debris ejected into the atmosphere would have catastrophic consequences for the entire planet, plunging it into a state of darkness and triggering a global environmental catastrophe. In the wake of the impact, the skies would have darkened as a thick blanket of dust and debris enveloped the Earth. This impact winter, as it's known, would have persisted for months, if not years, blocking out the sun and causing temperatures to plummet globally. The lack of sunlight would have had a devastating impact on plant life, the foundation of the food chain. With photosynthesis halted, ecosystems would have collapsed, leading to mass die-offs of herbivores, followed by the carnivores that preyed on them. The impact would have triggered massive wildfires, releasing huge amounts of carbon dioxide and other greenhouse gases into the atmosphere. The impact of the Chicxulub asteroid was a global cataclysm affecting every corner of the planet. The evidence for this widespread devastation can be found in geological layers around the world, known as the KPG boundary layer. This layer, dating back 66 million years, contains high concentrations of iridium, a rare element found in asteroids. The presence of iridium in the KPG boundary layer provides strong evidence that the extinction event was caused by an extraterrestrial impact. The KPG boundary layer also contains other telltale signs of the impact, such as shocked quartz, tektites, and soot from wildfires. While the asteroid impact theory paints a dramatic picture of sudden devastation, another theory points to a more gradual yet equally destructive force at play: massive volcanic eruptions. Our focus shifts now to the Deccan Traps in India, a vast volcanic region that holds clues to this alternative explanation. Imagine a period in Earth's history where volcanic activity was so intense, so prolonged, that it reshaped entire landscapes and spewed forth enough lava to cover continents. These ancient lava flows, some over 2 kilometers thick, cover an area almost the size of Europe. The Deccan Traps eruptions began millions of years before the extinction of the dinosaurs and continued for hundreds of thousands of years after. Volcanic eruptions, while visually spectacular, are also major environmental events. The Deccan Traps eruptions would have released massive amounts of sulfur dioxide, carbon dioxide, and other gases into the atmosphere, leading to a cascade of environmental effects. Sulfur dioxide, a powerful climate-altering gas, would have reacted with water vapor in the atmosphere to form sulfuric acid aerosols. These aerosols would have reflected sunlight back into space, leading to global cooling and potentially disrupting rainfall patterns. The combined effects of these gases, along with the sheer volume of ash and particles released by the eruptions, would have had a profound impact on the Earth's ecosystems. The timing of the Deccan Traps eruptions, coinciding with the extinction of the dinosaurs, has led some scientists to propose that these volcanic events played a significant role in the dinosaurs' demise. Could these eruptions have been the sole cause of the extinction, or did they deliver a final blow to an already struggling ecosystem? Proponents of the volcanic activity theory argue that the prolonged environmental stress caused by the Deccan Traps eruptions gradually weakened ecosystems, making them more susceptible to collapse. The release of toxic gases, acid rain, and climate fluctuations would have taken a toll on plant and animal populations, reducing biodiversity and pushing many species towards extinction. In this scenario, the asteroid impact, while still a catastrophic event, might have been the final straw, pushing an already stressed ecosystem beyond the point of recovery. The debate between the asteroid impact theory and the volcanic activity theory hinges on the interpretation of geological evidence and the timing of events. While the asteroid impact provides a sudden and dramatic explanation, the volcanic activity theory offers a more gradual and nuanced perspective. The presence of the Chicxulub crater, the iridium layer in the KPG boundary, and the global distribution of impact debris provide strong evidence for a catastrophic asteroid impact. However, the Deccan Traps eruptions and their potential impact on the global climate and environment cannot be ignored. The study of fossilized pollen and marine microfossils reveals a decline in biodiversity and changes in species composition in the millions of years leading up to the extinction event. While the asteroid impact and volcanic eruptions dominate the extinction debate, other theories propose alternative explanations, focusing on the gradual changes that were reshaping the Earth's climate millions of years ago. Imagine a world where temperatures fluctuate dramatically, sea levels rise and fall, and ecosystems struggle to adapt to the ever-changing conditions. During the late Cretaceous, the Earth experienced a period of significant climate change. Sea levels fluctuated, impacting coastal habitats and marine ecosystems. These gradual changes, while not as dramatic as an asteroid impact or massive volcanic eruptions, could have placed significant stress on dinosaur populations. Another theory proposes that disease played a role in the demise of the dinosaurs. While we often think of dinosaurs as mighty and resilient creatures, they were still susceptible to diseases, just like any other living organism. Imagine a world where a deadly virus or bacteria sweeps through dinosaur populations, decimating their numbers and leaving them vulnerable to other threats. The fossil record provides evidence of diseases that affected dinosaurs, including infections, parasites, and even cancer. The spread of disease could have been exacerbated by the movement of dinosaurs across continents, facilitated by land bridges that existed during the late Cretaceous. Some scientists propose that the extinction of the dinosaurs was not caused by a single event, but rather by a combination of factors, a perfect storm of catastrophes that ultimately led to their demise. This multi-impact hypothesis suggests that the asteroid impact, volcanic eruptions, and other environmental changes worked in concert to create a cascade of events that proved too much for the dinosaurs to overcome. Imagine a world already reeling from the effects of volcanic eruptions and climate change. Ecosystems are already stressed and species are struggling to adapt. Then, the asteroid hits, delivering a final, devastating blow from which there is no recovery. The extinction of the dinosaurs is a complex puzzle, and despite decades of research, there is no single definitive answer. The asteroid impact theory remains the most widely accepted explanation, but the role of volcanic eruptions, climate change, and other factors continues to be debated. Each theory has its strengths and weaknesses, and the scientific community continues to gather evidence and refine its understanding of the events that led to the end of the dinosaurs' reign. The study of fossils, geological layers, and climate models provides valuable clues, but the further back in time we go, the more challenging it becomes to reconstruct the past. While we may never know exactly what happened 66 million years ago, the search for answers continues to inspire new discoveries and deepen our appreciation for the incredible history of our planet. In the battle of the theories, the asteroid impact and volcanic activity stand as the two heavyweight contenders. Both offer compelling evidence, but discerning the true victor requires careful consideration of their strengths and weaknesses. The Chicxulub crater, a colossal scar on the Earth's surface, stands as a silent testament to the unimaginable power of the asteroid impact. Its age, coinciding precisely with the extinction event, combined with the global distribution of iridium and shocked quartz, leaves little doubt that a massive impact occurred. However, critics argue that while the impact was undeniably catastrophic, its effects might have been short-lived, allowing for potential recovery. The Deccan Traps, on the other hand, present a different kind of threat, a slow-burning, relentless onslaught of volcanic activity spanning hundreds of thousands of years. The Deccan Traps eruptions present a conundrum. Did they deliver a fatal blow to the dinosaurs, or were they merely a contributing factor to an already precarious situation? The answer, like most things in science, is nuanced. Fossil evidence suggests that dinosaur diversity was already in decline in the millions of years leading up to the extinction event. This decline coincides with the onset of the Deccan Traps eruptions, implying a possible link between volcanic activity and environmental stress. However, the decline is gradual, suggesting that dinosaurs were adapting, albeit struggling, to the changing conditions. This leads some scientists to propose a scenario where the Deccan Traps eruptions acted as a catalyst, weakening ecosystems and making them more susceptible to collapse. While the asteroid impact and volcanic eruptions dominate the extinction debate, it's crucial to remember that Earth's systems are interconnected, and events rarely occur in isolation. Climate change, disease, and other environmental factors likely played a role, weaving a complex tapestry of threats that ultimately led to the dinosaurs' demise. The asteroid impact becomes the final thread in a web of interconnected threats. Its suddenness and violence shattered the already fragile equilibrium of the biosphere, pushing countless species, including the once mighty dinosaurs, beyond the point of no return. The extinction of the dinosaurs, while a tragic loss, paved the way for the rise of mammals and ultimately our own species. It's a sobering reminder of the power of nature to reshape our world and the importance of understanding the forces that have shaped life on Earth. The dinosaurs, despite their reign coming to an end, left an indelible mark on our planet. Their fossils, scattered across every continent, serve as a testament to their former glory and provide us with a glimpse into a world long gone. From the colossal Argentinosaurus, longer than a blue whale, to the fearsome Tyrannosaurus rex, their skeletons inspire awe and wonder, reminding us of the incredible diversity of life that has existed on Earth. The study of dinosaurs, paleontology, is a journey through time, allowing us to piece together the history of life on our planet and understand our place within the grand scheme of things. By studying the past, we gain insights into the present and future, recognizing the interconnectedness of Earth's systems and the importance of protecting the delicate balance of life that sustains us. The extinction of the dinosaurs is just one chapter in the epic saga of life on Earth. Our planet has experienced 5 major extinction events, each wiping out a significant portion of life. Today, we face new challenges, from climate change to biodiversity loss, threats that demand our attention and action. The story of the dinosaurs reminds us that even the most successful species are not immune to extinction. It's a call to action, urging us to protect the incredible diversity of life on our planet. Remember to like this video and subscribe to the channel for more explorations of the cosmos and beyond.